Okay, today we'll be working on lesson 6.6a, properties of logarithms, and make sure that you have the right worksheet. Please also make sure that you have your calculator. We'll be using this for our lesson today. So in your graphing calculator, I want you to enter the following and record your answer to 3 decimal places. So let's start with number 1. Log of 40. That would be 1.602. Always remember that I want you to round to the third number or 3 decimal places, so 1.602. Now let's try to find the other side, which is log of, so log of 4. Now as you can see, I'm just putting log and the base is not showing. What does that mean? What does it mean? Just to review. What does it mean if there is no base? It means that the base is 10. And this is called common logarithms, and that's why we're using the log on the calculator. So this is going to be also 1.602, as you can see. Now as we are doing that, I want you to compare the two parts of each problem and try to come up with your own rule, okay? So log of 72 would be equal to what? 1.857. And go ahead and try the other one. So log of 9. See how I'm closing parentheses? And log of 8. And this is also 1.857. Now go ahead and do the number 3 on your own. And you'll see that number 3 is what? Go ahead, write it down. So enter the following into y equals and look at the table. So I'm going to go to y1 and I'm going to enter log of 2x. So log of 2x. And I'm going to go to y2 and I'm going to make it bold. So press enter once. Go to and put log of 2 plus log of x. So log of 2 plus log of x. So 1 in y1, 1 in y2. Now what I want you to do is to go ahead and graph it. So let's do that as well. Let's graph it. So this is the y1, and y2 seems like it's on top of it as if they are the same graph. Now to make sure if they are the same graph, I'm going to go to second table and compare the values. So y1 is the same for x0. For x1, they are the same. As you can see, they are the same everywhere. What does that mean? It means those two functions, log of 2x and the function log of 2 plus log of x, they are the same function. So what can you conclude? Compare them and try to come up with your own rule. So this is 2x, this is 2 and x. What do we do to that for those to become 2x? Also, let's compare those. 40, and here it's 4 and 10. What do we do to get 40? 9 and 8. Do we add them? Do we subtract them? Do we divide them? Do we multiply them to get 72? Again, if you look at number 3, you will get also the same. So 25 and 5. What do you do with those to get 25? So the rule is, if you have, for example, log of 15, you figure out that it's log of 5 plus log of 3, because 15 can be 5 times 3. So log of 5 plus log of 3. But somebody might tell me, okay, 15 and 1. If we multiply them also, we're going to get the same answer. So does that mean that log 15 plus log of 1 is going to be the same? Yes. Now let's try another one. Let's look at log of 40. Now think of two numbers other than 4 and 10. When you multiply them, you get 40. I can think of 8 and 5. So let's put this to the test. Is it true, like if we multiply those? So if we try to find the log of each one separately, are we going to get the same answer? Let's try it. So let's go to log. Let me get out of this. And let me go find log of 8, close parentheses, plus log of 5. Am I going to get the same answer? What do you think? Yes, 1.602. So no matter what numbers you take, as long as you multiply them and you can get 40, then you can, the log when you add them is going to be the same. So think of another number. 8 times 5 is 40. 4 times 10 is 40. What else? 2 times 20. Okay, I'm going to put this to the test. I'm going to try log of 2 plus log of 20. Is it going to be still the same? So let's try it. Log of 2 plus log of 20, because 2 times 20 is 40. Yes, I'm going to get the same exact number. So the rule is that when you, this is called the product property of logarithms. So the property you have discovered is called the product property of logarithms. It means if you have two numbers that can be multiplied, then you would have the same type of log. So if it's log of b, then it's going to be log base b of m plus log base b of n. You got it? So it has to be the same type of log. So since this is log of b, then each one of them should be log of b. And think of two numbers or two letters. When you multiply, you get mn. You're going to get m. Excuse me. So m times n, you're going to get mn. So that would be your answer. So that's the first rule. If they are being multiplied, then we can subtract them. Now go ahead, try to do 5, 6, 7, and 8 on your own. And then I'm going to do 8 with you, but please go ahead, pause the video, do 5, 6, and 7. Okay, now by looking at those, you can see that log of 4 is 0.602. Log of 40 minus log of 10 is going to be the same thing. They are the same thing. Now look at those two, 40 and 10. What do we do with 40 and 10 to get a 4? What do we do? 40 divided by 10 is 4. So since they are divided to get 4, then if you subtract their log, it's going to be the same thing. So if they are being multiplied, you add. If they're going to be divided, then you subtract. Now log of 8, how can you get log of 8? 72 divided by 9, you get 8. Okay. Now think of another number, 16 and 2. So let's put it to the test. If I have log of 16 divided by log 2, so log of 16 divided by 2, you get 8, right? So then it's log of 16 minus log of 2. Let's put it to the test and see what happens. So let's see, log 16 minus log of 2. Are you going to get 0.903? Yes, you're going to get 0.903. So if you have two numbers that you divide to give a number which is 8, then log of 8, which is 16 over 2, and log of 16 minus log of 2 would give you the same answer. No matter what two numbers you divide to get 8, if you subtract those two, it's going to give you the same answer. So now let's try to graph it. So on y, I'm going to put log of x. And on y2, I'm going to put log of 2x. So second delete to insert a number. So this is log of 2x. And then plus log or minus. I'm going to put a minus over here. Log of 2, because 2x divided by 2 would give you x. Now let's try to graph it. Looks like exactly the same, but I'm going to go to second table to double check. And as you can see, the y values are exactly the same. So what can you conclude from this rule? You can conclude that if you are dividing, like log of b of m divided by n would give you log of b, base b of m, minus log base b of n. So it has to be the same type of log. So if it's log of base b, it should be log of base b everywhere. But then m divided by n would be log m minus log n. You see that? So now we learned another rule which is called the quotient property of logarithms. Now these are two properties. Now let's move on to the third page. Now as well, I want you to go ahead and try to do the values. Log of 5 square. I'm going to do the first one with you. 5 square would give you 1.397 or 398 since you... Okay, let's try 2 log 5. Also, it's going to be the same thing. Now go ahead, do 10, 11 on your own, 12, log radical 6. Now remember 6, if you want to change it to a power, it would be 6. Remember the power on the inside divided by the index, and if there's no index, then the index is 2. So it's going to be 6 to the power. Okay, so if we go back over here, remember every time you have a radical, then you would look at the power on the inside divided by the index. So that would be 1 over 2. So then instead of radical 6, you can put 6 to the power half, but it's basically the same thing, okay? So just a reminder how to change from a radical to a power, okay? So let's try this. You can either put log of square root of 6. You're going to get that, which is 0.389. Or you can put, for example, log of 6 to the power half, or 0.5, it's also the same thing. You know what, you don't have to, but you can just move over to make it bigger if you want to. So 0.389, so whether you put it this way or this way, it's going to be the same thing. Now let's try 0.5, which is half, divided by log 6. Is it going to be the same answer? And yes, it's going to be the same answer. So I want you also to go ahead and graph it. Go to y equals and try to graph it. Please pause the video and try on your own. The functions that we have, or those, as you can see, number 10, they are the same. 11, they are the same, whether it's log 3 to the power 4 or 4 log to the power of 3, it would give you that. Again, radical, you can change it to a power if you want to. Half log 6 is going to be the same, and when you graph them, let's see, once you graph those, what's going to happen. So let me go all the way back, make it bold so we can really compare them. So press enter, now graph it. And now let's see, as you can see, the bold is going to be exactly the same for the positive values. So only for the positive values, not the negative. So let's compare that to the positive values. So go to second graph. I'm not going to go to the negative is going to be different. So that's why we always say that we cannot have a negative. Look, negative is going to be an error. So we're going to start comparing from 1, because we need positive values, all the way up. It's going to be the same thing. So exactly the same for x greater than 0. Okay, for positive values. Now, what does that conclude? And here we come to our third property of the day, which is power property, and we've taken this before. It's basically, if you have a power, you can just bring it down next to the log. You will have n log, and keep the same type of log. Like if it's log 6, it stays log 6. bm to the m. So that would be our third rule. So let's review the rules. 3 rules. The first one is going to be the product property. It means if they are multiplied, then you can divide the log, but you add the 2 logs. If they are being divided, then you can divide the log, but by subtracting. Now let's move on to the third rule. If there's a power, you move the power down and you multiply it by the log, okay? And the power is gone. So how can you use this in solving? Sometimes they will give you something like this. For example, log of, or 2 log of, let's say 3 plus log of 6 minus log of 2. And they ask you to go ahead and simplify it. So in order to do that, you have to use the rules. Now remember, you can go backward. So the 2 can go back over here. So it would be log 3 to the power 2 plus log 6 minus log 2. Now 3 to the power square is just, you can just put 9. 3 square is just 9. I'm going to put that. Addition, it means you're basically multiplying. So log 9 times 6 would be how much? 54. So log of 54 minus log of 2. Now remember, every time you are subtracting, it means you can go to dividing. So log of 54 divided by 2, which is log of 27. So this is how basically they use the rules. They might either ask you to simplify or they will ask you to expand. So it's according to the question. So I hope you understand this lesson. We'll continue tomorrow.